Let's play a game. I'll say a sentence, and you tell me what's happening behind the scenes. The bank can refuse to cash a check. Simple, right? But here's the question. Which bank? A river bank or a financial institution? And check. A chess move, a verification, or a piece of paper. Before machines can understand language, we need to understand how language actually works. The structure, the rules, the hidden layers that native speakers navigate effortlessly, but computers find mind-bogglingly complex. Welcome to Linguistic Essentials for NLP, where we decode the building blocks that make human language both beautiful and maddeningly difficult for AI. Let's start at the smallest level, morphology, the study of word structure. Take the word unbreakable. It's not atomic. It's built from 3 pieces. A prefix meaning not break, the root wordable. A suffix meaning capable of, put them together, not capable of being broken. These building blocks are called morphemes, the smallest units of meaning. Why does this matter for NLP? Because understanding morphology helps machines recognize that walk, walking, walked, and walker are related, handle new words they've never seen before, reduce vocabulary size by understanding word formation rules. Watch how the word internationalization breaks down. Inter plus nation plus, al plus size plus, Asian 5 morphemes working together to create meaning. Languages differ wildly here. English is relatively simple. Turkish? A single word can encode what English needs an entire sentence for. That's why morphology is critical for multilingual NLP. Now let's zoom out to syntax, the rules for arranging words into sentences. Consider the dog chased the cat versus the cat chased the dog. Same words, completely different meaning. Order matters. Syntax is like the grammar you learned in school, but deeper. It's the invisible architecture that makes this sentence make sense. The old man the boats. Wait, what? Read it again. The old is a noun phrase, elderly people. Man is a verb, to operate. The boats is the object. The elderly people operate the boats. Syntax helps us understand. Who did what to whom? Subject, verb, object. How do phrases nest inside each other? Why colorless green ideas sleep furiously is grammatically correct but semantically nonsense. For NLP, syntax is crucial because it reveals relationships. In John gave Mary a book, we need to know. Who's the giver? John, who's the receiver? Mary, what's being given? A book. This is called dependency parsing, mapping which words depend on which others. Watch how a sentence becomes a tree structure, with each word linked to its grammatical parent. But grammar isn't meaning. Enter semantics, the study of what language actually means. Take these 2 sentences. The cat is on the mat. The mat is under the cat. Different syntax, same meaning. Semantics looks beyond structure to capture the underlying concepts. This gets weird fast. Consider, time flies like an arrow. Fruit flies like a banana. Same grammatical structure, completely different meanings. In the first, flies is a verb, time moves quickly. In the second, flies is a noun, the insect. Semantics deals with lexical semantics. What do individual words mean? Bank has multiple meanings. That's polysemy. Compositional semantics. How do word meanings combine? Hot dog isn't a warm canine. Reference. What does it refer to in I saw a dog and it barked? That's coreference. For NLP, semantic understanding means knowing by and purchase are synonyms. Understanding, the robot cannot lift the table because IT is too heavy. What's heavy? The robot or the table? Recognizing that he kicked the bucket might mean he died, not literally kicked a container. This is where word embeddings come in, mathematical representations that capture semantic similarity. Words with similar meanings cluster together in vector space. But language isn't just about words and rules. It's about context. Welcome to Pragmatics, how we use language in real situations. Imagine you're at dinner and someone says, "Can you pass the salt?" Literally, they're asking about your ability to pass salt. But you don't respond, "Yes, I am physically capable." You just pass the salt. Why? Because Pragmatics tells us this is an indirect speech ACT, a polite request disguised as a question. Pragmatics covers implicature, implied meaning. Do you have the time? You don't answer, "Yes," and walk away. You give the time. Presupposition, assumed background knowledge. Have you stopped stealing? Presupposes you were stealing, loaded question. Discourse coherence, how sentences connect. John went to the store. He bought milk. We know he equals John, and the store is where he bought milk. No one stated this explicitly. Deixis, context-dependent references. I'll see you here tomorrow. Who's I? Who's you? Where is here? When is tomorrow? All depend on who says this, where, and when. For NLP, pragmatics is brutally hard. Sarcasm, irony, cultural references, unspoken assumptions. These require understanding beyond just words. This is where language models still struggle, and why context windows in GPT matter so much. So why does all this linguistic theory matter for building AI? Because every NLP task relies on these layers. Morphology helps with stemming and lemmatization, reducing words to roots-handling languages with complex word formation, reducing vocabulary size for neural networks. Syntax powers dependency parsing, understanding who did what to whom, question answering, extracting the right information, machine translation, restructuring sentences across languages. Semantics enables word sense disambiguation. Which bank do we mean? Co-reference resolution, linking pronouns to their reference, paraphrase detection. Do these sentences mean the same thing? Pragmatics tackles sentiment analysis, detecting sarcasm and tone dialogue systems. Understanding user intent beyond literal words, contextual understanding. Why ChatGPT needs conversation history. Modern language models like BERT and GPT learn these layers implicitly through training on billions of words. They develop internal representations that capture morphology, syntax, semantics, and even some pragmatics. But here's the limitation. They learn patterns without deep understanding. They're statistical approximators, not linguistic theorists. That's why the next generation of NLP combines deep learning's pattern recognition, power, linguistic knowledge for structure, and rules, world knowledge for context and common sense. Understanding these linguistic fundamentals isn't just academic. It's the foundation for building better, more reliable language AI. When you tokenize text, you're dealing with morphology. When you parse sentences, you're applying syntax. When you train word embeddings, you're capturing semantics. And when you fine-tune for dialogue, you're tackling pragmatics. Language is humanity's most complex technology, and we're teaching machines to master it, one layer at a time.